Hey everyone, welcome to homework 1.22. I'm going to go through the homework and then I'm actually going to go back and go over the last part of the classwork as well. So let's take a look at the homework first. So the first question says, to qualify for a loan from a bank, the total in someone's checking and savings account together must be $500 or more. Which of these inequalities best represents this situation? All right, so in looking for this, we notice that it has to be, must be 500 or more. Okay, this is a key point right here. And so if it has to be 500 or more, then it needs to be greater than or equal to. It could be 500, but it could also be more. And so that best is represented by this one where x plus y, so x the checking, the savings rather, because we have x here, and y the checking is greater than or equal to 500 total. It says complete the graph so that it represents the solutions to an inequality representing the situation. All right, so we need to decide, am I looking at this side or am I looking at this side? All right, and in order to do that, we're going to choose any point on our graph and then we're going to substitute in there. So the most obvious point to choose would be 0, 0. And obviously, if I have zero money in either account, that's not going to be greater than or equal to 500. So this side is an X, and this side is the check. And so we would go ahead and shadow or shade in this side. Okay? It says be clear about whether you would use a solid or dashed line. In this case, it is greater than or equal to, so it would be a nice solid line, not a dashed line. All right. That means that if we were to pick any point on this line, that would equal exactly 500, and that anything above this line is going to be greater than 500. Naturally, that means that anything down here is going to be less than 500. All right, and we could choose, if you wanted to choose a different point, let's say you chose 100, 100. 100 plus 100 is 200, which is less than 500, so that also, again, demonstrates that that is not a solution. Number 10 or 2, whatever you want to call it. The soccer team is selling bags of popcorn for $3 each. All right, bags of popcorn are on the x-axis, so those are our x, and cups of lemonade for $2 each. To make a profit, they must collect a total of more than 120. All right, we're looking at more than, not more than or not, at least 120, but more than, okay? So write an inequality, and it says to use P and C. We'll go ahead and use P and C, but remember that popcorn is X and lemonade is Y. So $3 per cup, per popcorn bag. So that's 3P plus $2 per cup of lemonade, and we need to make more than 120. All right, so now it says graph the solution set. So we can graph the solution by either solving for the x and y intercepts. So when popcorn is 0, what would the cups of lemonade be? When cups of lemonade is 0, what would the popcorn be? Or we can put this in slope-intercept form. I'm going to do both just for the purposes of this so that you can see that there are two ways to graph it. So let's start by looking at our y and x intercepts. So if we pretend that p is 0, then 3 times 0 would be 0. We'd be left with 2c. 2c equals 120. C would then have to equal 60. So when popcorn is 0, then cups of lemonade is 60. All right? Now if we were to do the opposite and we were to make this 0, C 0, and say how many things of popcorn would we need to sell if we didn't sell any lemonade, then we would have 3P equals 120. Divide both sides by 3. We get P equals 40. So popcorn would be 40 and we'd have 0 cups of lemonade in order for us to meet this constraint of 120. And so we can plot then 0, 60 here. We can plot 40, 0 here, and we can attach those and draw our line. All right, so that's one way to do it. The other way to do it would be to put this into slope-intercept form, which is a perfectly valid way to do that. Remembering that our p is our x, right? So 3x plus 2y equals 120. I want to put it in y equals, so I'm going to subtract 3x from both sides. All right, and so we get 2y equals negative 3x plus 120 divide both sides by 2, and we get y equals negative 3 over 2x plus 120 divided by 2 is 60. All right, so this is now the graph of the line. Now our y-intercept is 60, which, look, we got that right here when we found our y-intercept by plugging in 0 for x, right? And so we got the same answer, so that works. But now we can also add points between these two dots by doing our slope and going down 3 over 2. Now, 3 over 2 is pretty small when this graph is going by tens. So we can also think of negative 3 over 2 if we multiply the top and the bottom by 10, we get negative 30 over 20. That's equivalent, and that's more helpful because going down by 30 and over 20 is going to be a lot easier for me. So I can go down 10, 20, 30, and then over 20, 10, 20. Here's another point. So notice now that this is nice because it gives me another point along my line, and will make it a little easier to draw my line. And I can check, right, if I go down 10, 20, 30, and then go over 10, 20. So that gives me the exact same slope. This marks my point, so I know that's right. Now we're looking at a greater than situation, so I'm going to have a dotted line. And now I need to decide, am I going to shade on the left side or the right side? Well, now remember, easiest point to plug in there is 0. So if I were to plug in 0 here and 0 here, I would get 0 plus 0 is greater than 120. Again, that is not true. And so that tells me that the best side to shade would be above the line is going to give us a profit greater than 120. And if you wanted to be sure, you can test the point, for example, 2060. Let's plot 2060. If I plug that in here, 20 bags of popcorn would give us $60 plus, what did I say, 60 cups of lemonade gives us 120. That's already more. We can tell 180 is greater. So check, this one works. And again, we shaded in this side over here. All right. So we graphed that, and then it says explain how we could check if the boundary is included or excluded from the solution region. So we can, again, just look at this and see that we have a greater than sign, not a greater than or equal to sign. But we can also plug in numbers from the line. So if we were to plug in, for example, when we graphed it, we got that 20, 30 was on the boundary. If we were to plug that in, 3 times 20 plus 2 times, was it 30, greater than 120. We have 60 plus 60 is greater than 120. And that is not true. 60 plus 60 equals 120. It is not greater than 120. So the solutions on the line, right, the points on the line are not solutions. All right. Tickets to the aquarium are $11 for adults and $6 for children. All right, I'm going to look at my graph. I see that adults is my X. I'm just going to mark that for myself. And children are Y, because that'll help me to figure this out. An after-school program has a budget of $200 for a trip to the aquarium. If the boundary line in each graph represents the equation 11x plus 6y equals 200, which graph represents the cost constraint? All right, so budget means less than or equal to. So it's or equal to, which means we should have a solid line. That helps me to go ahead and eliminate A and D because those have dotted lines as answers. So the question now is, am I graphing shading in this side or am I shading in this side? Which side contains the solutions? And so again, as always, let me go ahead and plug in 0, 0. Because if I plug in 0, 0, I get 0 plus 0 is less than or equal to 200. That is true. And so I want to shade the bottom side, this side right here, because I want to stay under my budget. And so letter C would be my best solution. Just to make sure, we can always check a point, plug in a point above that. So let's plug in 10, 20. If we plug in 10, 20, we will get 11 times 10 plus 6 times 20, and it has to be, again, less than or equal to 200. We would get 110 plus 120 is less than or equal to 200. Well, this right here is going to be 230. 230 is not less, So that side does not work. We do in fact need to have this one with that side shaded in. And all of the solutions in this shaded area are solutions that would solve that inequality. All right, Tyler then fills a small jar with quarters and dimes and donates it to his school's charity club. The club member receiving the jar asked, "Do you happen to know how much is in the jar?" Tyler said, "I know it's at least $8.50, but I don't know the exact amount." Write an inequality to represent the relationship between the number of dimes, the number of quarters, and the dollar amount of money in the jar. All right, so he knows it's at least $8.50, which means it's greater than or equal to $8.50. Okay, what's in the jar has to be more than or equal to $8.50. Now, dimes are 10 cents, and that is on our x-axis, so 0.1 x plus 0.25, looking at quarters, y, quarters are on the y-axis, is greater than or equal to $8.50. Now it says graph the solution set to the inequality and explain what a solution means in this situation. So if we had no dimes and only quarters, right, that would be $8.50 divided by 0.25, which is 34. So that would be approximately here with 34 quarters. Okay? If we had no quarters and only dimes, we would do 8.5 divided by 0.1 is 85, so that would be here. So that gives us 2 points that we could then connect to form a line. Again, seeing that we would probably want to have a slope to help me fill in some of those points in between, let's solve for y. So we'd have 0.25 if we subtract 0.10 from both sides, 0.10x from both sides. We would get is greater than or equal to negative 0.10x plus 850. Divide both sides by 0.25. And we're going to get y is greater than or equal to. Now, for this one, I'm going to go ahead and I'm going to multiply both of those by 100 over 100 because that will bring this into a nice even number of negative 10 over 25. X plus 850 divided by 25. So remember when we did that, 850 divided by 25, we'll get our, 850 divided by 0.25, we get 34, which again, that's our y-intercept up there. Oops, I wrote 35 and I said 34. Here we go, let's fix that. All right, 34. Okay, so if we were to go 34 and then we're going down 10, so down to 24 and over 25, that's going to give me a point approximately here, right? Again, going down 10, so from 24 to 14, and then over 25 to 50. All right, and so you can see that we're building up some nice points that are going to lead to my x-intercept here, going down to 4, and then over another 50. Sorry, over another 25. So we're going down 4, like 50 is not right. Going down 4, and then over and over 25 to 75. About here, and that looks nice. Now it is greater than or equal to because he said at least, so we have a solid line. All right, and now we need to test a point. So he said greater than or equal to. Already I'm thinking that needs to be above the line, but just to be sure, I'm going to go ahead and test a point. If I put 0, 0 in there, that will not work, and so we get 0 plus 0 is greater than or equal to 850, which we know is not true. And so this is the side that we are shading, which means anything in that highlighted blue area is where our solution would be. Now it says, suppose Tyler knew there are 25 dimes in the jar. Write an inequality that represents how many quarters could be in the jar. So if he knows for sure there are 25 dimes, then 25 dimes times 10 cents, right, gives me $2.50. So that means $6 of that at least is quarters, right? So we would say 0, I'm still in highlighter mode. Let's change that. 0.25 y has to be greater than or equal to $6. And then therefore your number of quarters, if you want to continue to calculate that. 6 divided by 0.25 is 24. So that would mean that your quarters have to be greater than or equal to 24. All right. So Andre is solving this inequality, and he solves a related equation. So first he looks at the equation. He says, this seems strange. He thinks he made a mistake. What is his mistake? All right, so when he got to this, instead of dividing by x, right, because then when we divide by x, we have no more x, right? What should he have done instead? Well, if he had done 14x equals 8x, if he had subtracted 8x from both sides, he would end up with 6x equals 0. This tells me that x has to be 0. And so his mistake was dividing by the x's. We generally don't divide by the variable. We divide by what's in front of the variable, or we add or subtract. So he should have subtracted these terms instead of dividing by x. All right, number 14, Karen says, I bought 2.5 pounds of red and yellow lentils. If you don't know what lentils are, they're kind of like little beans. Both were $1.80 per pound. I spent a total of $4.05. Write a system of equations to describe the relationship between the quantities in Karen's statement. Be sure to specify what each variable represents. So make sure you tell me what they are, okay? So let's say that we decide the red lentils are X and the yellow lentils are Y. And this person says, I bought 2.5 pounds of red and yellow, but they were $1.80 per pound. I spent a total of $4.05. So you could list this as $1.80 per pound. And we have it's the same price for X and for Y. So we have 180 times the number of red lentils, and then 180 times the pounds of red lentils has to equal $4.05. So it's one of our equations. The other equation then would be X plus Y equals 2.5 pounds. Okay, so we can make that system of equations. We're saying that X represents the pounds of, X represents, yes, the pounds of red, and Y represents the pounds of yellow, okay? Because we don't know how many of each of those this person bought. Elena says that can't be right. Explain how Elena can tell something is wrong with Kieran's statement. So when these equations are graphed, let's think about what would happen. Sorry about that. Okay, so when these are graphed right here, if we were to graph them and put them into slope-intercept form, let's see what would happen. So if we do that, we would have y equals negative x plus 2.5 as one of our equations for this one. And then if I were to do the other one, right, I would have 180 y equals negative 180x plus 4.05 divided by 1.80. And when we divide by 1.80, we will end up here with, right, 1.80, negative 1.80 divided by negative 1.8, or divided by 1.80 gives me negative 1, which is the same slope as this. So these two equations have the same slope. And therefore, remember, when we have the same slope, they form parallel lines. And so that means that they would never intersect, and there would be no solution to this particular set of equations. So Karen says, oh, whoops, I meant to say I bought 2.25 pounds of lentils. Revise your system of equations to reflect this correction. So if instead of 2.5, Karen buys 2.25, does that change the equation? So that would then be, instead of x plus y equals 2.5, 5, we would have x plus y equals 2.25. Now, in this case, if we look at this equation with the other equation, so this would be y equals negative x plus 2.25, right? The other equation that we found over here would be y equals negative x plus 4.05 divided by 180, which would be 2.25. So now, instead of having an equation with the same slope but a different y-intercept and parallel lines, these are the exact same equation, and so these would be the exact same line, and therefore we would have infinite solutions. So it's not possible for us to tell for sure because there are so many different solutions that could be the answer. All right, let's take a look at the next one. Here is an inequality. Select all the values of x that are solutions to the inequality. So for number 15, you can do this by yourself because you are literally just plugging in possible values and seeing what is true and what works. I would suggest that you simplify this side by distributing that negative. So negative 7, and then this negative needs to be distributed. Minus 3x minus 2 is less than, let's distribute this to, negative 8x minus 8. And then we can combine like terms. So we have negative 3x, negative 7, and negative 2 become negative 9 is less than negative 8x minus 8. And then we can go ahead and continue to solve. So I would go ahead and continue to solve from here. I'm going to stop here because you can go from that point and then see what you would get and which of these values meet the constraints of this. All right, so I'll give you the hint that there are 4 answers. There's 4 possible answers, but you need to tell me what they are. Number 16 says, here is a graph of the equation, so they already graphed it. It says, are the points 1.5, comma, negative 4, and 0, comma, negative 4 solutions to the equation? Explain how you know. So 1.5 is, this is 1. Here we go. This is 1. So 1.5 would be here, and then down negative 4. 1.5 here. So that is not on the line. So that is not a solution. So this is no. And then 0, comma, negative 4 is here. So that's yes, right? So 1.5, comma, negative 4 is not on the line. But 0, comma, 4, 0, comma, negative 4 is on the line. B says check if each of these points is a solution to the inequality 6x plus 2y is less than or equal to negative 8. So 6x plus 2y is less than or equal to negative 8. So we're plugging these numbers in and seeing if they are solutions. So as an example, 6 times negative 2 plus 2 times 2 is less than or equal to negative 8. We get negative 12 plus 4 is less than or equal to negative 8. Negative 12 plus 4 is negative 8, so that is equal to, so that is a solution. 4, comma, negative 2. So 6 times 4 plus 2 times negative 2. I can already tell this is not going to be less than, because we get 24 minus 4 is less than or equal to negative 8. 20 is not less than negative 8, so this is not a solution. So 4, comma, negative 2 right here is not a solution, okay? And we determined that 2, comma, negative 2, comma, 2 is a solution, okay? So that would be a solid line. 0, 0. Well, if I put 0 in there, I'm going to get 0 plus 0 is less than or equal to negative 8. 0 is not less than negative 8, and so this is also not a solution. And then negative 4, negative 4. So if I plug that in, I'm going to get negative 24 minus 8 is less than or equal to negative 8. That'll be negative 32 is less than or equal to negative 8. That is true. So negative 4, check, is a great solution. So notice then that the solutions are going to be on this side of the line. So for our next, we did that, we shaded it. And it says, are the points on the line included in the solution region? Explain how you know. So are these points on this line part of the solution? And the answer would be yes, because when substituted, they equal our solution. They equal -8. And it is less than or equal to, right? That less than or equal to part is really important. All right, that's it for your homework video today. Your code word for today will be mouse. Mouse is your code word for today. And if you have any questions, please ask, reach out, text, whatever you need to do. Happy homeworking and see you tomorrow.